In this video, we are going to see about operational amplifier. Whatever we use today, whether it is a computer or a mobile phone or a car key, washing machine or any appliance, one thing is common, that is the integrated circuit. So this integrated circuit or ICs can be analog or a digital one. What is this analog IC? It can work with the continuous signal. For example, if you take a speech or you're speaking, it is an analog signal. So to process this analog signal, you need an analog IC. Whereas if you take the simplest example is take a logic gates, it will give only either a 0 or a 1 output. So that comes under digital ICs. So linear integrated circuits are designed to work with continuous or analog signal. For example, if you see here, I can give a sinusoidal input or a triangular input for a IC. So that comes under linear integrated circuit. And moreover, linear ICs show a linear relation between the input and output. So this is the output and this is the this is the input, there will be some linear relationship between the input and output. Op-amps are the basic building blocks of many electronic circuits, and this op-amp, particularly LM741, is one of the widely used op-amp which we are going to see in this video. Op-amps are available in different packages. You might have seen this 8-pin or a 16-pin or in metal type. So depending upon the application, we can choose which one. For different temperatures or in which environment you have to use, you can see you can use a particular package. So this is called the dual inline package, which we normally use for our projects or in our laboratory. And this is 16-pin. This is called metal can package and this is a flat pack. So depending upon your application, you can use it, and mostly we use this tip in our laboratory. What is this op-amp actually? Op stands for operational amplifier. This amp means amplifier. So operational means we know mathematical operations, whether it is a summer or a subtractor or a differentiator, integrator, whatever it is. Some mathematical operations you can do with an op-amp. And what is this amplifier stands for? Suppose you sing in a music concert, you need to amplify your signal without any distortion. Just your signal is very weak and it has to reach a larger number of audience. We just amplify the signal. So for example, you can see you are measuring a current using a current sensor. So the output of the current sensor will be very small, or it will be in millivolts. You cannot give that millivolts to your microcontroller or any other processor because it cannot drive it. So in such cases, you can amplify your signal and give it to the microcontroller. So op-amps are basically you can do mathematical operations and then amplify that weak signal. What is inside this operational amplifier? So if you break and see, it will be something like this. So what is this actually made up of? Only resistor, capacitor or transistor will be there. So if you see inside, some sort of circuit like this will be there. You need not worry about all these things because it doesn't matter to you. We are worried about how to use this one. Like if you take a mobile phone, we don't know what is inside the mobile phone, how it works. But we can learn how to use it. So in case of operation amplifier also, we should know what are the pins and how to use the pins for our application. That is enough. Now if you take an op-amp, you can see a small notch here. So what is the use of this? This indicates the starting point or the pin number 1 of the IC. So it is almost common for most of the ICs. You can see here to the left of this notch you have the number 1. If you see here the front view of this one, it will be numbering will be like this. So this is 1, 2, 3, 4. Then 5 starts from this side. So this is 5, 6, 7, 8. So you should not get confused and connect it in opposite order. Your IC will not work or it will get damaged also. So always try to find this notch and find the number 1 because each pin has different function. You can see here. This you can get it from the data sheet. Okay, so the first pin and the fifth pin, if you see, it will be for offset null. The second and third is for input and the sixth pin is for output. So now you see here, we need not draw this structure every time. We are worried only about 5 pins. So most of the application we will be using only these 5 pins. So one is the inverting input, non-inverting input, then 2 power supply pins and output. So we will see about these 5 pins now. We will see about the power supply connections. The power supply voltage will determine the output range of the op-amp. What do you mean by that? You can see here 2 pins will be there, power supply pins, V plus and V minus. So this V plus should be connected to the positive voltage. So it can be a 12 volt or 15 volt. Similarly, this V minus should be connected to either minus 12 volt or minus 15 volt. So this voltage will determine what will be the maximum output voltage of the op-amp. For example, if I give 15 volts, my output will be always till 15 only. It cannot exceed this 15 voltage. If I give 12 volts, the op-amp output will not exceed 12 volts. So the output can never exceed the power supply voltage. Basically, op-amp acts as a differential amplifier. It means that it always amplifies the difference between the two input signals. So we have two input signals. V0 is equal to A into Vd, where A is the gain of this operational amplifier and Vd is the difference between the two input signals, V1 minus V2. You have to remember here plus is connected to V1 and minus is connected to V2. So I am writing V1 minus V2. For example, let us take this A, that is the gain of this operational amplifier as 10 and this Vd, difference in input voltage is 5 volt. So in such a case, V0 will be some 50 volts. But what I told earlier, op-amp output cannot exceed the power supply voltage. So here it is, I am giving a supply voltage of plus 15 here and minus 15 here. So in such a case, if you draw the relation between the output voltage and difference voltage Vd, it will follow the linear curve till 15 volts only. After that, you see here the output exceeds the 15 volt. So this is the saturation voltage. The op-amp output will saturate at this voltage 15 volt. So here you will get only 15 volt and here it is minus 15 volt. So in this case you will get only 15 volt as output. Now we will see about the inverting input. So that is the second pin, minus symbol. So what I am going to do is first I will ground the other input and I will use only the inverting input and see how an op-amp will respond. So if you give something to the inverting input, why it is called inverting input? Whatever you give, it gets the output will be 180 degree out of phase with the input signal. That is why it is called an inverting input. So V0 is equal to A into Vd. That's what we have seen. So here V1 is 0, because it is grounded. So 0 minus V2, you will get V0 is equal to minus A into V2. So this is the output in case you are using only inverting input and you are grounding the other input. Now, instead of a signal, I am giving a sinusoidal signal here. Instead of a constant, I am giving a sinusoidal signal here. So output should be 180 degree out of phase. So what you will get is a sine signal 180 degree out of phase with the input. So here we have a positive, then negative. Here you have a negative and positive, and the signal is amplified because there is a gain. So the signal gets amplified, but it will be 180 degree out of phase. Next, we will see about non-inverting input. So for non-inverting input, I am giving the input and the plus pin V1 and the other pin I am grounding it. So in this case, what will be V0? V0 is equal to A into Vd. So here V2 is 0. So you will get A into V1. So the output is in phase with input. Similarly, let me give a sine signal here. So if I give a sinusoidal signal, what I will get? Same signal, but it gets amplified. So in the next we have this offset null pin, which is the first pin and the fifth pin of an op-amp. Actually, when the two inputs are 0, the output should be 0. As the difference voltage is 0, output should be 0. But sometimes it may not be there. A small offset voltage will be there. So in such cases, you can adjust these knobs to using some pot. We can adjust and bring it to 0. This is like in measuring instruments. Before starting the experiment, we will check whether the indicator is at 0 position. Otherwise, we will try to bring it to 0 position. So it's something like that. Let us recall what we have seen so far. Linear ICs are designed to work with continuous or analog signals. They give you a linear relation between the input and output. Op-amps are the basic building blocks of many electronic circuits. 5 important things you have to remember is inverting input, non-inverting input, and one output will be there. Apart from that, you have two power supply connection pins. One is the plus voltage and this is the minus voltage. Op-amp basically acts as a differential amplifier. It amplifies the difference between the two input voltages. If you like the video, do subscribe to Read Electric Vehicle channel and share it with your friends. Thank you.